Welcome and hello. This is an update video in HEC HMS, and I've titled this one Green-Ampt Sorptivity. This is a new option in the Green-Ampt loss method. The Green-Ampt loss method now has a second polarity parameter option called Sorptivity. The first option was available in previous versions of HMS that is called the wetting front suction. So we're going to walk through a tutorial in this video to demonstrate this new sorptivity feature in the loss method for Green-Ampt. On the screen here is the first link I'll have in the description of this video. It talks about the features that are new to version 4.13 in HMS. The feature that I'm going to be talking about is right here, modified sorptivity parameter for the Green-Ampt loss method. All right, so if you wanted to click on the link right here, post wildfire hydrology modeling with Green-Ampt, I think this is the webpage with the tutorial that we're going to be using. So go ahead and click on that. I'll leave a second link to this page in the description as the second link. All right, so let's get started. Go ahead and scroll down, and what you want to do is click to download the initial project files, which is right here, Arroyo Seco Sorptivity Initial.7z. All right, so that has downloaded. I've also unzipped it. So you can just do like a right click extract to unzip the zip files. And then where I want to put that is right here in my project directory. So I'm just going to drag it over. And then inside that, we have our files associated with an HMS project. And the .hms file is right here, Arroyo Seco _ ga.hms. All right, I'm going to fire up my HMS version 4.13 and then File, Open, navigate to that HMS file, Browse, Updates, 3, Project, Arroyo Seco, and then Arroyo Seco ga.hms, and select. Open. Let's go ahead and see what we have here. I'm going to expand the basin model. We have a base model, and then we have a pre-condition. This is before the wildfires. I've already modified the symbology a little bit, so I'm only seeing certain layers, which you can do as well if you go up to View, Map Layers, and then toggle off some of the unneeded layers. I just wanted to get an idea of how many subbasins we have. In this video, we will show the new sorptivity feature built into the Green-Ampt loss method. So let's look at that right now. Here I'm going to select a subbasin, and then down here in the Components editor, with the subbasin tab selected, the loss method is Green-Ampt. So if I click on the loss tab now, we have some of those details. And what's new in version 4.13 is this capillarity parameter option. Wetting front suction is what has always been used for version 4.12 and previous, but now there's a new type of capillarity parameter option. So now we have to actually select between wetting front suction and this new option, which is sorptivity. So when we click sorptivity, the suction parameter is going to disappear, and then the sorptivity parameter will appear, and it's going to be in units of length per time to the 1/2. So there's sorptivity. Here it is. We need to provide values for sorptivity for all of our subbasins that use this particular capillarity parameter option. All right, so for now, I'm just going to switch that back and then make some global edits so we don't have to do this one subbasin at a time. Also, I wanted to bring up 4.12. So here on the right is 4.12. Here on the left is 4.13. If I select the subbasin in 4.12, select Green-Ampt for my loss method, click on the loss tab, we can now compare 4.12 and 4.13. It looks like capillarity parameter option is now new. And then below that, we have suction, conductivity, and percent impervious. So yeah, that's all the same. But again, if we select the sorptivity option, we need to specify that rate. All right, let me move that over to the side. Sorptivity is defined as the rate at which water is absorbed into dry soil due to capillary action, expressed in units of length per square root of time. This is especially useful at the early stages of infiltration prior to saturation or ponding. All right, up on the screen here, I've got some equations. So what we have is the cumulative infiltration depth at time t for Green-Ampt, and then also the Phillips model, which uses sorptivity. This capital S is the sorptivity. And then you've probably seen all these other parameters before. So this is the equation right here. Sorptivity equals this value here, the square root of everything we see here. And then down below, I've added a few typical values in units of inches per hour to the 1/2. So for sand, In coarse soils, it could be as high as 4, but then for clay, it could be as low as below 1. So I just wanted to add this in here so when we run our calculations, we can just do a ballpark check to make sure we're in a typical range of values. All right, so let's go ahead and do that. Let's calculate the sorptivity for all of our subbasins here in the map. So I'm going to, first of all, change this back to wetting front suction, save. I'm going to go up to the parameters menu, loss, grain and amp, unselect that filter. So I'm seeing all of the subbasins now. I'm going to make a couple of these fields a little bit skinnier. Well, what I'm actually should probably do first is change this capillarity parameter option to sorptivity. So that'll be the same for all of my subbasins. Going to copy, paste, 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 paste. As you notice, we no longer will have a suction value, but we'll have a sorptivity value. All right, so that's it. We need to calculate this value here for sorptivity. So I'm going to click apply, and I lost all of my changes. So I thought apply save changes, but let's go ahead and try that again. Okay, I'm not going to change that anymore. I'm not going to click the apply button yet. Let's go ahead and put some numbers in for sorptivity. Click on calculator. This is the expression calculator. All right, so I want to calculate sorptivity. I'll select that right there. Now in this box, this is where we provide the expression which will calculate the sorptivity. So just to double check, if I click on test 5, click calculate, it populates 5. Okay, just wanted to do a quick check to make sure that it's working. Let's bring up that equation once again right here. This is the equation I'm going to use. So let's start with the power function. Double click on power, change the exponent to 0.5. So everything under the square root symbol will be here, 2 times the hydraulic conductivity, which we have right here, that grid data. And then we have our psi, that's our wetted front suction, multiply by that grid right there. And then finally, the initial porosity and effective porosity. I think that's the same thing, at least for this data. So let's go ahead and double click. All right, I'm going to move the equation out of the way here and then click on calculate. Again, we want numbers sort of between 1/2 and 4, and it looks like we're getting that. So I will click on close and then apply. Okay, cool. So that's saved. That's good. 1.14, 1.16, 1.14. We have a 0.39 here, so that would be more of a impervious soil, but nothing super high, so that looks good. All right, well that was kind of it for the new feature. But let's go ahead and run a model. So apply and close. What I had in my notes and what the tutorial says to do is actually use a different, create a copy of this basin before making that change. Oops, I forgot. I'm just going to rename it though and just call this post. So rename basin. Then I'll just call this post. Go ahead and click on save. And then up here in the compute menu, simulation run manager, I already have a simulation run that's set up. Let's just click on edit and double check what we're dealing with here. So the basin model does use post. And then we have a MET model. We have a control specification. I'm not going to change any of that, but you're welcome to make those changes if you want. Apply, close, and then let's run the model. So run and compute. Okay, so it says it's finished. Let's take a look at some results here. Open up simulation model within the results tab, and then click on our simulation run here. The instructions say to scroll down here to the Arroyo Seco _USGS, click on outflow, hold down the control key, and then click on observed flow. So we have, let me click the graph button here. Okay, so we have the calculated outflow versus the observed outflow in this series right here for the simulation. What we learned in this update video was about the sorptivity capillary parameter option within the Green-Ampt loss method in HEC HMS version 4.13.